very important concept, that is duality in linear programming, right? So the numerical that has been given to us is called as the primal numerical. It is called as the primal numerical. And what we are going to do here is saying, we are going to see what is a dual numerical, or what is a duality in the what is the duality in the linear programming. So now for every linear programming problem, that is LPP, there is a unique LP problem which is related to it and which involves the same data which describes the original problem. Okay, so what I'm trying to tell you is that for every LPP, that is for every primal numerical, there is another unique LPP which is nothing but a dual numerical which is related with it. So every primal and dual, they are related to each other, and they use same data which describes the original problem, right? So this is called it is called as the duality in LP. So there can be you have a primal numerical, right, and you have there is another unique LP problem which is using the same data of your original problem, and which is related with your primal numerical. So that particular numerical is called as the dual numerical, right? And this dual numerical is unique in the characteristics, right? So the primal numerical is called as P and the dual numerical is called as D. So I'll be explaining it in more detail when we move ahead in this particular format, right? And the variable of the variable of your dual numerical are called as the dual variables, right? Now I want to just tell you more. Let's consider a simple language for explaining the duality in LP problem. So what will be there? There will be a primal solution. There will be a primal numerical, and I can convert a primal numerical into a dual numerical, right? So this dual numerical is unique, and let me write here convert. So I can convert a primal numerical into dual numerical, or vice versa. I can even convert a dual numerical into a primal numerical. And right, so this both your primal numerical is also unique only, but you get, after conversion, you get a unique dual numerical. And for this, for this, you do not require some separate data. For this, you have the same data that has been given in the original problem, and because of that only, that makes them the unique problem. So right, so it is just the conversion of the original numerical that we have into something another which uses which is called as a dual numerical, which uses the same data as that has been given into the original problem. Now why this is required, or why to do this, but why to convert one original problem into another unique dual numerical problem, and why there is need of that particular thing. Now what are the important and interesting factors in the duality? Let we discuss first, and then you'll be understanding. So important and interesting feature, what we can say, feature in duality. Suppose that if I'm having an original problem which are having large number of rows, right? So you can see, when there are more number of constraints, right, the number of rows in your simplex table increases, and it becomes very, very complex when there are more number of rows, right? So no, I can say that if my problem is having, so if the primal solution or the primal problem or the original problem has many number of rows and less numbers of columns, right? So the computational procedure for to frame out the duality can, particularly, the computational procedure gives a dual dual numerical which has less rows and more columns, right? So handling columns is okay, but if there are more rows, then particularly what will happen, the computation becomes more and more complex. So what will happen, I can convert my primal numerical, which is a unique type, into a dual numerical, which is also of unique type, which will have less rows and more columns, which we want. And then particularly what will happen, there will be ease in handling this particular problem. Also, the dual problem can be used for testing the accuracy in your primal numerical, right? So, particularly the theory may seem a bit complex, but when we are going to see the computational procedure or conversion procedure, you'll be finding it very interesting and it is very very easy. So as of now, don't block your mind that this is something that sir is telling is very difficult to understand. When I'll be making you understand the conversion process, so it is very simple. So let's understand the construction process of a dual problem or a dual numerical, right? So just a second. Okay, construction process of a dual problem. So let's consider any hypothetical problem that whereas maximize the z as c1 x1 plus c2 x2 plus c3 x3 till cn xn, right? Where where which is subjected to the constraint subjected to a11 x1 plus a12 x2 plus a13 x3 plus a1n xn, and which is less than or equal to b1, right? There are some another constraints like a21 x1 plus a22 x2 plus a23 x3 plus a2n xn less than or equal to b2. There are multiple constraints like this, and let's say that last constraint is a m1 x1 plus a m2 x2 plus a m3 x3 plus a mn xn less than or equal to bm, right? Where your x1 comma x2 comma x3 comma dash xn are all greater than or equal to 0, right? So this is our simple primal numerical where we have maximized objective function is there c1 x1 plus c2 x2 plus c3 x3 dash plus cn xn, and we have some constraints that are given, right? So now the above problem is the primal, so the dual can be given as, I'll be just writing, and after that we can discuss, or I will be telling you the simple rules to remember, and you'll be finding it very very simple then, right? So it can be written as, so earlier it was maximize, so the dual will be minimize w is equal to b1 y1 plus b2 y2 plus dash 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 bm ym subject to a11y1 plus a21y2 plus a31y3 plus dash 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 am1y1 greater than or equal to c1. Nextly, it will be a12y1 plus a22y2 plus a32y3 plus dash 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 am2ym greater than or equal to c2. There can be multiple constants like this, and it will be a1n y1 plus a2n y2 plus a3n y3 plus dash 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 plus amn ym greater than or equal to cm. And here the variables are y1 comma y2 comma y3 ym all greater than or equal to 0. Now here, if you know, I'll be just drawing a line here, and now let's compare this, right? So now here you can see the maximization is turning to be a minimization problem, and vice versa. So if your original problem is a maximization problem, then your dual will be a minimization problem, or your original problem is a minimization problem, so your dual will be a maximization problem, right? Now you will be seeing the variables are different. So earlier x1, x2 and x3 were the variables, and here it is y1, y2 and y3 are the variables. Your y1, y2, y3 are the they are called as the dual variables, right? So now if you see the previously the first constant construction in your dual is a11 y1 plus a2 y2 plus a31 y3 plus dash 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 greater than or equal to c1. So in your maximization type, all the constraints will be less than or equal to type. Here you can note all the constraints are less than or equal to, and here all the constraints are greater than or equal to in the minimization type, right? Even if you see the construction of the constraints in your dual problem, so here a11, here it is a21, here it would have been a31 and am1. So here you can see all those are coming in a single line only, a11, a21, a31, am1, which is here. So that is forming that particular constraint. And c1, if you see, so this c1 is nothing but here c1 is the coefficient of x1 here. Similarly, C2 is the coefficient of x2 here. Similarly, your Cn is the coefficient of particularly here we have written Cn, that is right. So there is some relationship that is appearing, right? If you see your second constraint in your dual, which is this one, so here you can see it is the addition of a12, a22 till your am2. So a12, a22, a32 till am2, right? So there is some relationship that is appearing, and now I'm going to tell you that how to convert a maximization problem into minimization problem. Now this is something where there is no numbers. When the numbers will be introduced into this, it becomes a very easy to understand, right? But firstly, let's particularly decide some rules, and those rules will be helping us to move further and will be also making your tension to disappear, right? So let me disappear your tension first. Rules for conversion from primal to dual, right? So the very first rule is, if the primal contains n variables and m constraints, the dual will contain opposite of it. It will have m variables and n constraints. So this is going to happen, right? So if the primal contains n variables and m constraints, so the dual will have m variables and n constraints, right? Second one, the maximization problem in primal becomes a minimization problem in dual and vice versa. So if your primal is a maximization problem, so your dual will be a minimization problem. If your primal is a minimization problem, then your dual will be a maximization problem. So vice versa will happen. Every time, if it is a maximization problem, whether it is a dual or a primal, your maximization problem will have less than or equal to type inequality, and minimization will have greater than or equal to type of inequality, irrespective of whether it is a primal or a dual. This is to be remembered. So maximization problem will have less than or equal to type inequality, and minimization will have greater than or equal to type of minimality, right? Now, so hence we can write constraints of less than or equal to type becomes greater than or equal to type in dual. So constraints of less than or equal to type in primal becomes greater than or equal to type in dual, and vice versa. Right? Now very, very important. The coefficient matrix of primal is, or you can say the coefficient matrix of dual is a transpose matrix of your primal. This is very, very important. 6. There will be new sets of variables. So y1, y2, I won't be repeating here it again, but they knew the constants C1, C2, C3, Cn in the objective function of primal will appear in RHS of the constraints in the dual. Right, very, very important. The 6th point is very, very important. 7th point, the constants B1, B2, B3 till your Bn, Bm in the RHS of constraints of primal appear in objective function of the dual. Very, very important. This 6th and 7th point are very, very important, and the application of that I will be going to tell you now when we are going to solve this solve this small numerical immediately, right? So let's take a very simple numerical, right? So we are going to continue this lecture till 12:30. I don't know how much, but I'm going to finish this problem of duality so that the link is maintained. So the normal in question paper, the problem will be construct the dual, right? So let's consider a numerical. Maximize z is equal to 3x1 plus 5x2 subject to twice of x1. I will be writing subject to twice of x1 plus 6x2 less than or equal to 50, thrice of x1 plus twice of x2 less than or equal to 35, 5x1 minus 3x2 less than or equal to 10, x2 less than or equal to 20. Here it is x1 greater than or equal to 0, and x2 greater than or equal to 0, right? So here we are going to see if all these if it is a maximization problem, you have to check the sign of the inequalities. We have written in the rules that if there is a maximization problem, the inequalities will be less than or equal to. If there is less than or equal to inequality in all the constraints for a maximization problem, then it is okay. If it is not, then you have to convert it into a less than or equal to type of inequality by multiplying it by minus 1 to LHS and RHS as well. Now it is here, it is okay. First statement, let y1, y2, y3 and y4 be the dual variables. All right. Now it was in primal, it is the maximization. So in dual, it will be a minimization. So I'm changing the for maximization it is z, and for minimization I'm putting it as w. Right. Now the coefficients of the objective function in your dual will be the RHS of your constraints, right? So what I'll be writing here is that 50, right? This 50 y1 plus 35 y2 plus 10 y3 plus 20 y4, right? So this 50, 35, 10 and 20 has been taken into consideration. Right now, this is the objective function. I have to write the constraint subject to. Now this addition of all these variables will be what will be my will be the framing of this particular constraint. So 2 y1 plus 3 y2 plus 5 y3. In your fourth constraint, there is no variable consisting of x1, so we'll be leaving it at this particular stage only. So 5y3. Now it is a minimization type. So minimization type, it will be greater than or equal to, right? And here the RHS will be your coefficient in your objective function. So here it will be 3. Similarly, your second constraint will be 6y1 plus 2y2 minus 3y3, right? Now it is of x2 only. Your fourth is related with x2 only, plus y4 is greater than or equal to 5, right? And you can write y1 comma y2 comma y3 comma y4 greater than or equal to 0. This finishes your conversion. Khatam. you have constructed a dual for your primal solution, right? So I'm repeating what we have done. It is minimization. So maximization get converts into a minimization. Z gets converted into W. So all this RHS side, that is 50, 35, 10, 20 will be considered as the coefficients into your objective functions. Here you can see 50, 35, 10 and 20 appearing subject to all this x1 will be appearing in a single constraints only, the coefficients of x1 for all the this thing. So 2, 3, 5. Here it is for x2 it is 6, 2, 3 and it is 1 greater than or equal to 5. Question. It is construct a dual of given primal. It is maximize z is equal to thrice of x1 plus 10x2 plus twice of x3 subject to twice of x1 plus thrice of x2 plus twice of x3 less than or equal to 7, thrice of x1 minus twice of x2 plus 4x3 is equal to 3, and x1 comma x2 comma x3 are greater than or equal to 0. So this is a maximization type of numerical, right? So all constraints should be of the less than or equal to sign, right? So less than or equal to sign is there in first constraint, but in the second constraint if you see you do not have that particular case. Here it is equal to type of you can say it is the equal to type of sign that it is there, and but if it is a maximization problem, what we have set in rules is that we'll have to convert this equal to sign into a less than or equal to sign, right? And then only we can move ahead. So before starting to construct with the duality, you'll have to reframe this particular numerical, right? So now particularly 3x1 minus 2x2 plus 4x3 is equal to 3 can be expressed as the combination of as the pairs. We can express this particular equation, so can be expressed as a pair, as pair of inequalities. So what will be that pair? First pair will be 3x1 minus 2x2 plus 4x3 less than or equal to 3, and 3x1 minus 2x2 plus 4x3 greater than or equal to 3. So meaning of this two pairs is nothing but your given equation 3x1 minus 2x2 plus 4x3 less than or equal to 3. Or we can even express this as 3x1 minus 2x2 plus 4x3 less than or equal to 3, and minus 3x1 plus twice x2 minus 4x3 less than or equal to minus 3. Less than or minus 3 is not visible. I'll be writing here minus 3. So if you see, I've converted this inequality into what I require is this particular format. Now in this equation you can see here we have that format, and here also we have that particular format. So now I can write it now as therefore the maximize z is equal to thrice of x1 plus 10 x2 plus twice of x3 subject to twice of x1 plus thrice of x2 plus twice of x3 less than or equal to 7. You can write it as 3x1 minus 2x2 plus 4x3 less than or equal to 3, and it is minus 3x1 plus twice of x2 minus 4 of x3 less than or equal to minus 3, right? But it is not as simple as what it is seeming to of. Here what we'll have to do is that here we'll be considering one more while considering the dual variables, we'll be writing let y1 y2 dash and y2 double dash be the dual variables. Now here x1 y1 variable is related with this particular constraint 1, and this is nothing but constraint 2, right? So y1 is related with this, and here for the first equation will be y2, here will have y2 dash, and here for this equation will be having the y2 double dash, right? So if I move ahead, now particularly minimize w is equal to, so what I can write is here 7 y1 plus 3 y2 dash minus y2 double dash. So if you see, so it is 3 y2 dash and minus 3 y2 dash. So that has been taken care of when I'm putting it in the equation, right? Similarly, subject to, so here it is same 2 y1 plus 3 y2 dash minus y2 double dash, and it will be, this 3 is to be considered, it is a minimization, so greater than or equal to 3, right? Similarly, next constraint what we can derive, similarly what we can go is 3 y1 minus 2 y2 dash minus y2 double dash is greater than or equal to 10. Lastly, what we have is 2, okay, it is not visible properly, so I'll be using the next page. I'll be also writing the previous what we have, so that there won't be any confusion, and you will be understanding it properly. So we had maximize z is equal to thrice of x1 plus 10x2 plus twice of x3, and we started with the, this is the original numerical only, what we converted it into the new format, twice x1 plus thrice x2 plus twice x3 less than or equal to 7, 3x1 minus 2x2 plus 4x3 less than or equal to 3, minus 3x1 plus 2x2 minus 4x3 less than or equal to minus 3. So we converted and we have finalized our two constraints along with the objective function 3y2 dash minus y2 double dash subject to 2y1 plus 3y2 dash minus y2 double dash greater than or equal to 3. It is 3y1 minus 2 y2 dash minus y2 double dash greater than or equal to 10. Lastly, our last constant is 2y1 plus 2y1 plus 4 y2 dash minus y2 double dash greater than or equal to, now this 2 is to be taken into picture 2. So here what we are going to do here, here your y1 is greater than or equal to 0, and y2 dash and y2 double dash are sign restricted. Y2 dash and y2 double dash are sign restricted. You should be writing this. So those particularly will change depend upon the sign. So this is how this particular numerical will work out.